11.1b homework. Solve systems of equations. Okay, so there's another way of solving a system of linear equations, which is through the elimination method. And the way we would do that is we would add one multiple of one of these equations to one multiple of another one of these equations. And if two of the variables, right, one variable in one and one variable in another, for instance, y here and negative y there, have the same coefficient but opposite sign, if you add those together, they should cancel out. So they eliminate each other. Okay, so now we're going to say 1x plus 1x is 2x, and positive y plus negative y, or positive y minus y, is just 0y, or just goes away. So we just add the rest of this together. So we say negative 6 plus 10, which should give you a 4. So now what you end up with is 2x is equal to 4. So now the way we finish solving for x is we undo the multiplication of x by 2 by dividing by 2, and whatever we do to one side, we do to the other. And that gives me x is equal to 2. Now we're not done at this point. We still have to go back and solve for y. So in this case, we don't have something already solved for y, so we need to go and we need to plug something in. So wherever we see an x, we are going to plug in a 2, and then we just continue on with the rest of the equation. Now, it doesn't matter which one of these you plug in into. You can either do it in equation number 1 or equation number 2. Okay, so now we want to get this y by itself. So we have to undo this addition, or this positive 2 there, and we undo that by subtracting 2. And whatever we do to one side, we do to the other. That gives me y is equal to negative 8. Now, we end up with x is equal to a 2 and y is equal to a negative 8. So we end up with x and y, positive 2, negative 8. That's the answer. If we were sufficiently motivated at this point, we would plug it back into the original equations, and if it made both of them true, then we would be able to check this off and say, yes, that is the correct answer. This is another example. This one's already been set up so that if you add these together, one of the variables will cancel out. So we would say x plus x is 2x. We would say y plus negative y. Those would cancel out. We would say 2 plus 12 is a 14. We would undo the multiplication of x by 2 by dividing by 2. Whatever you do to one side, you do the other. And you would end up with 14 divided by 2 is 7. Now at this point, you go back and you plug 7 into one of the equations. 7 plus y is equal to 2. Minus 7, cancel, cancel. Y is equal to negative 5. So in this case, our ordered pair would be a 7 and a negative 5. So if we solve the next one, now in this one, we're going to add these together. Again, this was already set up for you have a negative y and a positive y. But 4x plus 1x is a 5x. Negative y plus y, those cancel out. 15 plus 10 is a 25. Then we undo the multiplication of x by 5 by dividing by 5. Whatever we do to one side, we do to the other. It gives us 5. 25 divided by 5 is 5. Then we plug it into one of the equations. I'll plug it into the second equation because why not? It doesn't make any difference, really. So that gives me x plus y is equal to 10. We solve for y by undoing or getting rid of this positive 5 by subtracting 5. And whatever we do to one side, we do to the other. That gives me y is equal to a positive 5. Now I have to go back and write it as an ordered pair. So we have 5. We have 5. And we have a 5. All right. All right, let's move on to the next one. So we add these two together. This is already set up for us. We have a positive and a negative x. When we add those together, they will cancel out. We have 4y plus 7y, which gives us 11y. We have 12 plus 10, which gives me 22. We undo the multiplication of y by 11 by dividing by 11, and whatever we do to one side, we do to the other. It gives me y is equal to 2. We go back and we plug it into one of the original equations. I'll just do this first one just because why not? Make sure you plug it in the right place. So in this case, we are going to say x plus 4y, y being 2, equals 12. So we say x plus 4 times 2, which is 8, is equal to 12. We solve for the x by undoing the addition of x by 8 by subtracting 8. Whatever we do to one side, we do to the other. It leaves me x is equal to 12 minus 8, which is 4. Then we go back and we plug it in. No, in this case we actually have both of our values. So we have our 4 and we have our 2. And the last one on this page, use the elimination method to solve the following system of equations. In this case, nothing is solved for. Now, if we wanted to eliminate the x's, we'd have to find the LCD, or LCM, of a 5 and a 7. So LCM are least common multiples, so that'd be multiples of 5 would be 5, 10, 15, 20, 25, 30, 35, so on and so forth, right? Multiples of 7 would be 7, 14, 14, 21, 28, 35. So the LCM of a 5 and a 7 is 35. Another way to do it is we would want to find the LCM of a 1, which is the coefficient of this y right here, and a 3. And the LCM of that is 1, 2, 3, or just 3. Right, 3, 6, 9. Obviously, the first one that is the same multiple of both is a 3. Now, generally speaking, you want to pick the smaller LCM. That just makes your math a little easier. Now, so I'm going to eliminate the y's, and I'm going to do that by getting rid of, or making sure that the coefficients of both of these are the same 3. So the bottom was already a negative 3. That's great. So what it means is I have to multiply this entire first equation by a 3. So we say 3 times 5x gives me 15x. We say 3 times y, that gives me 3y. We'd say 3 times negative 15 would give me negative 45. So we got those. Now, at this point, we would just add those together. So we don't need this anymore. We already multiplied it through. We add these together now. Now, another thing you have to make sure is that they not only have the same coefficient, but the opposite signs. Okay, so in this case, we have a negative 3y and we have a positive 3y, so same coefficient, opposite sign. That's great. So when we add these together, they will cancel out. So we say 7x plus 15x is 22x. And we say negative 3y plus 3y, cancel out. And then we say negative 43 plus negative 45 will give me a negative 88. Then we undo the multiplication of x by 22 by dividing by 22. And whatever we do to one side, we do to the other. It gives me x is equal to negative 4. Now we're not done because we only have the x value and we need both the x and the y value. So we're going to go and we're going to plug it into one of our original equations, that x value of negative 4, and solve for the y. It doesn't really matter which one you choose. I'm going to choose the first one. So that gives me 5 times negative 4 plus y, which is equal to negative 15. 5 times negative 4 is negative 20 plus y is equal to negative 15. We undo the subtraction of y, or the negative 20 by adding 20, and whatever we do to one side, we do to the other. Those cancel out, leaving y is equal to 5. So the ordered pair on this one is a negative 4 and a 5.